Good day, everyone. Okay, so welcome to our second discussion. And this time we are going to look at how to determine the turning point of a parabolic function. So this is what this lesson is going to be about learning how to find the turning point of a parabolic function. So we have already seen how to sketch a parabolic function. And if we were to just recap it, what we've just seen is that if you are to sketch a parabolic function, there are times where it comes out like that. There are times where it comes out like that. So one of the things that characterizes a parabolic function is that when it is cup-shaped, there is always the point that is the lowest in that curve, and there is that point which is always the highest when it's cap-shaped. So this point which is highest or lowest is what we call the turning point of a parabolic function. See, so that's the point that we refer to as the turning point. So the question that we'd like now to know is, suppose you want it, how can you find it? So when it comes to finding the turning point of a parabolic functions, there are many techniques for doing so. And one of the easiest techniques that is employed all the time is by using something known as the axis of symmetry of a parabolic function. You see that? But I'm not going to demonstrate that here, but instead I'm going to demonstrate how to find the turning point using the second technique, which is the technique of completing the square. It's just that the technique of completing the square, it can be tested in many different contexts, like when you're doing paper 2, the circle, where you need to know the center of a circle, and sort of. So we'll just practice that method in accordance with the turning point, so that we can see that if you complete the square, how can you extract the coordinates of a turning point of a parabolic function from that new version of the equation of a parabola? You see. So to demonstrate how to find this point, we are going to look at a few examples, but now we are going to look at problems where we are given the explicit equation of a function, and our goal is to find what is the turning point of that function. You see. So the first example that we're going to look at, it goes as follows. So you are given that determine the turning point of y is equals to x squared minus 4x plus 7. So you can be given something like that. And then the question goes on to say, can you find the equations of the turning point of this function? So how do we go about finding equations of the turning point? So to find the turning point, this is how we proceed. See, so the first thing that you do is you take the equation of the parabolic function and then you complete the square in it. You see, so which means now we have to recall how exactly do we go about completing the square. So to complete the square of a parabolic function, this is a procedure which only requires 3 steps. You see, so the first step, every time when you're completing the square of a parabolic function, you must always make sure that the quadratic term of the equation must always have a coefficient of 1, and it must be a positive 1. So when it is a case like this one where already the coefficient is +1, the next thing that you do is you just open an empty bracket. And then after opening that empty bracket, what you're going to do is you're going to find the square root of that initial term, which is the quadratic term. And you find the square root of that term, you will find that it's x. Then the next thing that you're going to do now is you're going to move on to the next term. And then now for the next term, what you simply do is you extract only the coefficient, which is just this part. So you only take the coefficient, and that coefficient that you take, what you simply do is you take it and divide it by 2. So when you divide it by 2, it will become -2. So you place -2 here, you close the bracket, then you square outside. So immediately after squaring outside the bracket, you put a negative. You see? Then after that negative, what you do is you take the number that you have inside the bracket, in this case, which is this one, and then you square that number. So if you take this number and square it, it will become 4, then you place it next to that negative. Then after that, you put the constant that was originally there. So you bring down 7 and then you get that. Then what you have to do is to simplify. So when you simplify, you get x minus 2 squared, then plus 3. So when you take an equation of a parabolic function, which was like this originally, and you write it in this form, this is what we call completing the square. You see, so completing the square is just a procedure of restructuring the equation of a parabolic function with the goal of obtaining certain information out of it. And it just simply involves transforming the equation into something which looks like that. You see. So now when you have the equation which looks like this in completed the square form, the next thing that you do is you can now write down immediately your turning point. So therefore, what is turning point? So the turning point that we're looking for is what? So to find the turning point, remember a point, it is something which is described by two things. It is described by what we call an x coordinate and what we call a y coordinate. You see that? So if you want to find an x coordinate of a turning point, what you simply do is you look at the completed square expression, and wherever you have that squared bracket, you take what is inside and equate that to 0. So if you picture this in your own mind, and let's suppose you take that thing, x minus 2, and equate to 0. So when you equate to 0, you see that you obtain x equals to 2. So this x equals to 2 that you obtain there is the x coordinate of the turning point that you're looking for. So which means we now know that the x coordinate is going to be 2. Then for the y is always that constant that lies outside together with its sign. So that constant that you always get outside, like this, 1, this plus 3 that lies here, is always the y coordinate of your turning point. So which means now your turning point is just going to be 2, 3, and then it's done. See. So this is the technique that you must practice very well in order for you to master the art of finding the turning point at ease. You see that? It's just that at most time, the reason why I'm actually going for this technique is because in exams, they will give you an equation of a parabolic function in which the square has been completed already. Then they will say, write down the turning point. So if they say write down, it means you don't have to work it out. So every question in maths which says write down, it means already you must be able to see the answer. So in order for you to see the answer, you must only have the equation in this format. Then you just extract your information out. You see. But I used a very simple example to demonstrate this technique. Now what you're going to do is to look at a much trickier example for doing the same thing. So what we have now is, let's look at another example. So let's say find the turning point of y is equals to 3x squared minus 7x plus 15, like that. So at times you can be given something as hard as this one. So one might say, okay, why am I saying that is hard? So it's not really hard, but it's hard because you will see that there will be fractions involved in calculation. And most of the time, when fractions are involved, you have to be extra careful with that. So now let's see how can we find a turning point in this problem. So to find a turning point in this problem, we proceed as usual. We take the quadratic equation and complete the square. So as we complete the square, what we simply do now is, remember I say that this coefficient must always be plus 1, but in this case, it is not plus 1. So what do you do in cases like this? So in a case where the coefficient of the squared term is not 1, what you simply do is you pull it out, that is you factor it out. So you pull out x, and every time when you pull out something, everything else must be divided by that. So since I pulled out 3 here, this will remain as x squared. So since I pulled out 3 from this, I just divide by 3, so I get 7 over 3 x. Since I pulled 3 here, I get plus 5, like that. Then, after 3 has been pulled out, if you look in the interior of this square bracket, you will see that the interior is looking exactly like what we need. So the thing that is in the interior is something that we can work with. So what we're going to do is we're going to keep 3 outside as we continue completing the square of what is inside. So to complete the square of what is inside, we follow the same procedure. So first thing, we open a bracket, and then we find the square root of x squared, which is x. Then the next thing is we check the next coming coefficient, which is negative 7 over 3, and we divide it by 2. So whenever you have a fraction and you want to find its result when divided by something, what you simply do is you take the divisor and multiply the denominator, and then you'll get minus 7 over 6. Then now when you do that, you close the bracket, then square. Then always remember, after closing the bracket, there is always a negative that comes. But what follows after that negative? So what follows after that negative is always the square of the number in the interior. So what you do is you take the number that is inside the bracket, square it. So if you square 7 over 6, you will get 49 over 36. Then you bring in the plus 5, which is remaining there. So we bring in plus 5, and then we have that. You see. So the next thing that we do is we can simplify what is inside the bracket. So we have 3 bracket x minus 7 over 6 squared. Then we can see now that this can be written as common factor 36. So I will have 5 by 36, then subtracting 49, like that. So this is what I'm going to have. Then the next thing that I'm going to do now is I am going to then remove the square bracket. So the square bracket has to be removed. So to remove the square bracket, what I do is I multiply by 3, which is outside. But now be careful. The one common mistake that most people do is they take this 3 and then they come and multiply here, and then they take it and multiply there. So it's wrong. So don't do that. So the 3, whenever you're multiplying the square part of the parabolic function, you don't put it inside, but what you do, you just place it outside. So you're not going to do that. You see. So what you're going to do instead is you just keep it outside. So it's 3, then you have x minus 7 over 6, then squared. Then this side, you can take 3, then multiply this number. But if you take 3 and multiply this number, it's just going to divide into the bottom. So here finally we'll just have 5 by 36 minus 49 over 3 into 6. So we just see that this reduces to 12. You see. So now that we have that, then now our turning point can easily be spotted. So therefore, what is the turning point? So therefore, the turning point that we're looking for is as follows. So the turning point, so remember, to find the x coordinate, you take the interior equal to 0. So when you take the interior equal to 0, you will have x minus 7 over 6 equal to 0. So we see that x is simple 7 over 6. So that part is fine. So we see that x is just 7 over 6. Then the next thing is we take that guy there and simplify it. So what do we get there? So because I don't have a calculator with me, what I'm going to do is we know that this guy here, which remains outside, is always the y component of the turning point. So all the time you should know that the term that remains outside there is the y component. So if you have a calculator, you're going to simplify it, but I'm going to leave it like that as 536 minus 49 over 12. So that becomes your turning point. So yeah, this is how you find the turning point all the time when you're given a parabolic function and they say find it. But there are much easier technique, but this one is of much importance as it's going to be popping up quite often in many different areas of maths. Otherwise, thank you guys for watching. Like and subscribe if you enjoy or you find these lessons helpful. And it will be good also to hear your comments about these videos, or what you would like me to improve, or what I should add, or what video should I, or what topic should I also work on. So it will be good to hear that. Otherwise, see you next time. Bye.